Hello friends, my name is Manoj Chaudhary and welcome to today's session on sequences and series. So today we will discuss all about geometric progression. So if you remember in my previous video, we already discussed what exactly is a sequence is, what is the meaning of series, what is the meaning of progression. Then we also discussed three types of progressions, that is AP, GP and HP, and how to identify this AP, GP and HP in a sequence. So right, so in lecture number 2 or in video number 2 we covered or we revised arithmetic progression. Now it's time to revise geometric progression. So now how to identify a sequence in geometric progression. So there is a one simple trick to identify sequence in geometric progression. So just find the ratio of two successive terms. So just find out ratio of two successive terms of that sequence, and if the ratio of two successive term every time is constant, then we say that sequence is in geometric progression. Let's try to understand this condition of geometric progression with one simple example. So here I am considering one sequence with the digits, let's say 4, then 12, 36, 108 and so on. So right, so let's say this is the sequence. Then how to identify this sequence is in GP? To identify the sequence in GP, just try to take a ratio of these two terms. So right, so I'm talking about ratio of 12 by 4. So if you observe, the ratio of 12 by 4 is 3. Then try to take a ratio of 36 with 12. If you divide this 36 with 12, ratio is 4. Then try to divide this 108 with 36, obviously the ratio is 4. So what is your observation? So if you take a ratio of two successive terms, so I'm talking about successive, not any random terms, friends, just divide two successive terms. So like 12 with 4, if you observe, that ratio is 3 in this case. 36 by 12, ratio is 4. 108 by 36, the ratio is 4. If the ratio of two successive terms of any sequence remains same or remains constant throughout, then we say that sequence is in geometric progression. So right, so try to remember this condition for geometric progression. Ratio of two successive term is always constant, and in this case that constant is 4, and we denote it by symbol R, and it is called common ratio. So right, if you remember, this ratio is called common ratio, and as we already know, first term of sequence is denoted by small a. So this 4 is nothing but a, and this R, which is a very important term, is called common ratio of geometric progression. So here I am mentioning the sequence is in geometric progression. If you remember, in previous video we discussed arithmetic progression. So friends, what is the difference between AP and GP? In case of AP, if you observe, the difference between two successive terms remains same, but in case of GP, the ratio of two successive terms remains same. So in case of AP, difference between the two terms, and in case of GP, ratio of the two successive terms. So this is the difference between arithmetic progression and geometric progressions. Okay, then in general mathematical language, condition for GP is T of n plus 1 upon Tn is always constant. So right, this is the condition for any sequence in geometric progression. So what is the meaning of this? So let's try to understand this thing. So if I assume 12 as a Tn, then the next term will be T of n plus 1. So friends, if you take this ratio of T of n plus 1 upon Tn, means they are talking about 36 divided by 12. So right, so this is T of n plus 1 and this is nothing but Tn, and the ratio in this case is 4. So right, if I change the terminology, instead of this 12, if I say Tn is 36, then the next term is symbolically obviously T of n plus 1, and if you take that ratio T of 1 plus 1 upon Tn, so in this particular case T of n plus 1 is 108, and Tn is 36. So this ratio is 4. So right. So this is the symbolic meaning of this. So this is the condition for geometric progression. T of n plus 1 divided by T of n is always constant, and that constant in this particular example is 4. Okay, then let's try to find the next term of geometric progression, very important term, that is nothing but nth term of geometric progression. Symbolically we denote nth term by Tn. So right, so let's try to find nth term of geometric progression or Tn. So let me tell you once again, friends, nth term or Tn is not a last term of the geometric progression, right? It is nothing but a general term. This is also called general term of arithmetic progression or geometric progression. So right, so this is also called general term because this Tn will represent each and every digit, each and every number given in a sequence. So therefore, Tn is also called general term of any sequence. So let's try to understand, or let's try to find the general term of geometric progression. So here I am considering a sequence in GP. So let's take a same example, or if you want, let's change the pattern. So let's say it's a 2, 4, then 8, then 16, then 32, and so on. So this is the sequence. And if you observe, friends, if you take a ratio of two successive terms, so means I'm talking about 4 divided by 2, this ratio is 2. 8 divided by 4, ratio is 2. 16 divided by 8, ratio is 2. 32 divided by 16, ratio is 2. So this clearly indicates this sequence is in geometric progression. Let's write the basic things about this geometric progression. First, the first term of the sequence is nothing but a. So first term of the sequence is a is equal to 2, and the common ratio in this case, that is r value, is 2. If you observe, this ratio remains same throughout, and that is nothing but r. So r value in this case is 2. Now let's try to find formula for Tn. So as far as symbolic presentation is concerned, this 2 is nothing but the first term of sequence. So let's mark this as T1. This 4 is T2, 8 is T3, 16 is T4, and 32 is T5, and things goes on. And Tn is nothing but any term in that sequence. So it depends on, if I specify n as a 7, that indicates 7th term of that geometric progression. If I say n value is 15, then we say 15th term of geometric progression. So right, if I say n value is, let's say, 4, then it indicates 4th term of geometric progression. That's why Tn is any term that belongs to this sequence or in geometric progression. So it represents that. That's why we say, therefore we say the Tn is nothing but the general term of geometric progression. So right, so this is the nth term or also general term. So don't say it's a last term. It's not a last term of the geometric progression, but it is nothing but any general term or any number. It represents any number from that sequence, right? Okay, so let's try to find a formula for Tn. So here I am starting with basic things. So let's try to write the T1 first. So what is a T1? T1 in this case is 2. So right, so T1 in this case is 2. So let's mark this as A. Then how to obtain T2? So do one simple thing, multiply this T1 with this common ratio, right? That is 2. So this T1 in this case is 2, and we are multiplying with R. So right, so is it T1 in this case is A. So here I am changing a pattern little bit. T1 in this case is A, and this 2 is, I am talking about R. So this is AR. The second term in this case is AR. How to obtain T3? Simply multiply T2 with R. So right, R in this case is 2. If you multiply T2 with 2, understand 4 into 2 is 8. So right, so T2 is AR, and this 2 is nothing but R. So here I am taking 2 as R. So this AR into R becomes AR square. So don't get confused here. The first term is also 2 and the ratio is also 2. So don't get confused. So here I am taking this 2 as a R value. If you want to obtain 4, do a simple thing, multiply T3 with R. So right, what is T3? AR square, and if you multiply it with R, you will get AR cube. So let's understand this thing with one more example, how to obtain the successive terms of our geometric progression. So if you observe, the first term is A, second term is AR, third term is AR square, and fourth term is AR cube. And by observation, if you want, you can write down the fifth term according to this sequence. If you observe, the digit is 4. If it is a fourth term, then index is 3. Try to observe this pattern. If it is a third term, then index is 2. If it is a second term, then index is 1. So right, try to understand. If it is a fourth term, then index is 3. If it is a fifth term, then answer is A raised to 4. This is just on the basis of observation here I am writing, right? So let's understand this thing with one more example, how to find nth term of geometric progression. So here I am taking actual symbolic presentation. Let's say the first term of geometric progression is A. How to obtain the second term? Simply multiply this first term by R. That is nothing but the second term of geometric progression. If you want third term of geometric progression, multiply this T2 with R. So that becomes AR square. So right. So every time multiply with R, you will get the next term. If you multiply T3 with R, you will get AR cube as a fourth term. If you want fifth term, simply multiply T4 with R, it becomes AR raised to 4. And just simply to find the nth term, just observe this pattern. If you observe this pattern, A is common throughout. If you observe in this pattern, A is common throughout. So therefore, here I am taking this A common. So right. So which is a part of this formula. Then if you observe, there is something happening with this R. So in a first term, there is no R as a symbolic present, but you can mention it as R raised to 0. So right. Then in a second term, it is R raised to 1. So try to observe what is happening with the power of R. So if it is a first term, then index is by minus 1. So that is 1 minus 1, 0. If it is a second term, what is 2 minus 1? 2 minus 1 is 1. If it is a third term, power to this R is 3 minus 1, that is 2. If it is a fourth term, then power to this R is 4 minus 1, that is 3. If it is a fifth term, then the power of R is 4. So it is always less than 4. So whatever the term that you are trying to find, power of R is always less than 1. Now try to understand this, friends. If it is a n, then the power of R must be less than n by 1. So AR raised to n minus 1. So here we got formula for nth term of geometric progression by observation. So formula for nth term of geometric progression is AR raised to n minus 1. So right, this is the thing. So overall, here I am writing the geometric progression. So if T1 is the first term, T2 is the second, T3 is the third term, T4 is a fourth term, and Tn is any general term belongs to the geometric progression, then we write T1 as A, T2 as AR, T3 as AR square, T4 as AR cube, and Tn as AR raised to n minus 1. So this is the way that we select terms of geometric progression. And please remember this very important formula for nth term of geometric progression. Tn is AR raised to n minus 1. This is very important formula. So right. Okay. So let's understand the importance of this formula with this simple example. So here I am considering one simple example of the sequence 4, 12, then next one is 36, next digit is 108, and obviously the next one is 324, right? Okay, so this sequence is in GP. The reason is quite simple. The ratio of successive term is always constant here. So this is nothing but the first term of this geometric progression. So A value in this case is 4. And if you take a ratio of any two successive terms, whatever you want, so like a 12 divided by 4, right? Is it 3? So the ratio in this case is 3. If you divide this 36 with 12, so right, so here let's divide this 36 with 12. Obviously you will get 4, and that is nothing but R, or the common ratio. So R in this case is 4. So common ratio is 4. First term is also 4. So right. So sorry, common ratio. So let me correct it, friends. Sorry for this mistake. 12 by 30, 36 by 12 is 3. So this is the common ratio. So here I am correcting this thing. So this R value is 3. Okay, so the common ratio everywhere is 3. So take any ratio of any two successive terms, you will get the value of R. So right, now we want to identify nth term of this geometric progression, and formula for nth term is AR raised to n minus 1. So this is the formula that you have to remember. Formula for nth term of geometric progression is Tn is equal to AR raised to n minus 1. So here I am substituting these two values, that is A equal to 4 and R equal to 3 in this formula. So this Tn becomes A is 4, R is 3 raised to n minus 1. So here we got this formula. This is 4 into formula for nth term representing this example. Okay, now let's indicate this 4 as a first term, that is T1, T2 is 12, T3 is 36, T4 is 108, T5 is 324. Now, why this nth term is also called general term? The reason you will realize after doing these few calculations. So here I am taking n equal to 1. If you take n equal to 1, that indicates T1. So it's a 4 into 3 raised to n in this case is 1, so 1 minus 1. So right, so if you observe, I am keeping this 4 as it is. This is 3 raised to 0. Anything raised to 0 in maths is 1. So final answer is 4 for the first term. And if you observe, the first term of this example is 4. So right, so here we got the first term of this example. Now let's try to find the next term. So here I am considering, let's say, n equal to 2. So I'm applying the same formula. Let's substitute n equal to 2 in it. It's a 4 into 3 raised to 2 minus 1. So it's a 4 into 3 raised to 1. So 4 3s are 12, and you will observe second term of this example of geometric progression is 12. So try to observe the second term in this case is 12. Let's take any random term. Let's try to find this fourth term. So right, so fourth term in this case is 108. Let's cross check with this formula. So here to find a fourth term, I am substituting n is equal to 4. So let's say for n equal to 4, this becomes T4. So 4 into 3 raised to 4 minus 1. So this is the formula. I am substituting n is equal to 4 in this formula. So this is 4. It becomes 3 square. 3 square is 9. 4 into 9 is 36. And here we got fourth term of this geometric progression, and let's cross check whether it's a 36 or not. And if you observe in this example, the fourth term, so I'm talking about n is equal to 4. So is it n into r raised to n minus 1? Sorry, here I am making few mistake. So it may be because of quick in the calculation. So it's a 4 minus 1 is 3. Sorry for this mistake again, friends. So this 3 raised to 3 is 27. So 27 into 4 is 108. Sorry once again. So this is in a hurry. So here I corrected that mistake. So this is 3 raised to 4 minus 1. And this 4 minus 1 is 3. So 3 cube is 27, and 27 into 4 is 108. So let's cross check whether the fourth term is 108 or not. And it is. If you observe, the fourth term of that sequence is 108. So what I am trying to tell you here is what is the importance of the nth term of geometric progression. Why this nth term is so important in any sequence or for any sequence. So nth term is nothing but general term of that sequence. Nth term is nothing but general term of that sequence, and it can represent any element from that sequence. If you want fifth term, just substitute n equal to 5, and whatever the terms not given also you can find out using this formula for Tn. Let's say if I want 12th term of that sequence, which is not given in this example. If you observe in this example, only up to fifth term is given. So right, so if you want the 12th term of that sequence, it's quite simple. Just substitute n equal to 12 in this formula. So right, if you substitute n equal to 12 in this formula, you will get 12th term of that sequence. So therefore Tn is called general term of that sequence, or In this particular case, Tn is nothing but general term of the geometric progression, and by selecting any n value, you can find out any number from that sequence. If you want a seventh term of that sequence, just substitute n equal to 7 in this formula. If you want 15th term of that sequence, just substitute n equal to 15 in this formula. If you want 10th term of that sequence, then directly substitute n equal to 10 in this formula. So right, so that's why this is very important term in geometric progression. So once again I am repeating, the nth term of geometric progression is ar raised to n minus 1. So please remember this very important formula. So right, okay, then the next point you have to note down for the problem solving purpose. If the product of numbers is given, if the product of numbers is given, on the basis of this information, product of numbers in GP is given, then how to select numbers in GP? The question is how to select numbers in GP. How to select numbers in GP. So let's say it's a question of 3 numbers in GP. So let's select 3 numbers in geometric progression. If the 3 numbers are in geometric progression and product E of that 3 numbers is given, on the basis of this condition, let's select 3 numbers of geometric progression in this way: A, then AR, and A divided by R. So please try to understand, this is the first number, A is the second number, and this is the third number. This is the way that you have to select 3 numbers in GP provided product of all these 3 numbers is given. So what is a reason behind it? So why we select these 3 numbers in this way? So try to understand, friends, if the product of these 3 numbers is given, that is 1 into 2 into 3 is given. So what will happen? So if you multiply these 3 numbers, that is A by R into A and A into R, let's say it is given equal to something 8, for example. So then this helps in simplifying the question, because one of the unknown get cancels out. So this R get cancels out. What is left is A cube is equal to 8. And from this you can easily find out the value of A. Once we got A, we can find out the value of R. And once we know the value of A and R, we can easily find out all these 3 numbers. So this is the simple reason behind selecting 3 numbers in GP in this particular way if the product of 3 numbers is given. Then what if 4 numbers of GP are required? So let's try to select 4 numbers of GP provided product is given. So once again I am repeating, product of 4 numbers is given. On the basis of that, you have to select 4 numbers in GP. So let's select the 4 numbers in this way: A into R, then A by R, then directly AR cube and A divided by R cube. So friend, this is the way that you have to select 4 numbers of GP if the product of 4 numbers is given. So this is first number AR cube, second number A divided by R, third number A into R, and fourth number AR cube. So please select 4 numbers. This will simplify your question very easily. What if it is a question of 5 numbers in GP? So if you want 5 numbers in geometric progression, so let's say it's a question of 5 numbers in geometric progression, but with this condition, product of all the numbers is given, then please select all these numbers with this sequence: A, then A into R, then A divided by R on this side, AR square on right hand side, then A divided by R square on left hand side. So this is the way that you have to select 5 numbers in geometric progression if product is given. So this is the first number, A divided by R square, second number A divided by R, third number is A, fourth number is AR, and fifth number is AR square. And definitely this hint will help you in solving these questions on 3 numbers in GP, 3 numbers in GP, 4 numbers in GP, and 5 numbers in GP provided product of these numbers is given. Then the next question arises, what if product of the numbers is not given? So please write down the note number 2. If how to select numbers in GP. So please write down how to select numbers in GP, numbers in geometric progression if product is not given or product is not given, right? So let's say the product of the 3 numbers or 4 numbers or 5 numbers is not given. In previous case the product was given, but in this case product is not given, and on the basis of that you have to select numbers in GP. So let's take a question on 3 numbers in GP. Let's say we want to select 3 numbers in geometric progression. Then the way that you have to select 3 numbers in GP is the ordinary way. So we already discussed. If you observe here, we already mentioned, this is the important discussion that we already discussed. If a sequence is in GP, then in ordinary cases, select the numbers, first number as A, second number as AR, third number as AR square, fourth number as AR cube, and so on. So this is the trick that you have to use if the product of numbers is not given. If the requirement is of 3 numbers, then first number is A, second number is AR, and third number is AR square. So select these 3 numbers in this way. First number is A, second number is AR, and third number is AR square. If you want to select 4 numbers in GP, 4 numbers in GP, and once again I am repeating, product is not given, then start with A, AR, AR square, and AR cube. This is the way that you have to select 4 numbers in GP. This is first, this is second, this one is third, and this one is fourth. Then how will you select 5 numbers in GP? So let's select 5 numbers in geometric progression. So 5 numbers in GP, select in this way: A, AR, AR square, AR cube, and the last one is AR raised to 4. So right. So here I am mentioning this A as a first number, AR is a second number, AR square is a third, AR cube is a fourth, and AR raised to 4 is fifth number in geometric progression. So in examination, or in given problem, first of all, read carefully whether the product is given or not. So I discussed here both the cases. So please observe this note number 1 and note number 2. So note number 1 was all about product of numbers is given, and note number 2 is all about product of numbers is not given. On the basis of that, we selected 3 numbers or 4 numbers or 5 numbers of GP. So this hint or these 2 notes will help you in solving problems on geometric progressions, right? Okay, then the next thing is all about finding sum of first n terms of sum of first n terms of GP. So how to find sum of n terms of GP? In short, we write it as Sn. So how to find Sn in case of geometric progression? So right. So how to find sum of n terms of geometric progression? Let's understand what is the meaning of Sn. If I say a geometric progression is with the term T1, T2, T3, T4, so on up to nth term, let's say Tn. So n may be anything. If they say n is 7, then it will reach up to the T7, that is 7 terms. So if I say sum of n terms, means symbolically it is Sn, and what sum indicates addition. Obviously you have to add first n terms of geometric progression. So what you have to do here is just add all the n terms of geometric progression. So this is the thing, but we cannot do these things manually. So obviously you have to shorten this particular thing with formula. But there are 3 cases that you have to follow while finding Sn. Case number 1, what if R, the ratio is less than 1? So we know what is ratio. Ratio means it is a ratio of two successive terms like t2 by t1. So right, so you can find out this r on the basis of ratio of two successive terms, and please observe whether this r is greater than 1, less than 1, or equal to 1. On the basis of that, we will discuss three cases of SN. The case number 1, when r is less than 1. If r is less than 1, then please use formula for Sn as a times 1 minus r raised to n divided by 1 minus r. So this is the formula that you have to remember to find sum of n terms of geometric progression if r is less than 1. Then the case number 2, there is a slight change in the formula if that ratio is greater than 1. See, if you take a ratio of two successive terms, if it is, let's say, 2 divided by 4, the ratio is 1 by 2, which is less than 1. This might be the possibility, but there might be a case where you will observe this is a 4 divided by 2 and ratio is 2, which is greater than 1. So here you will observe in few sequences the ratio is less than 1, or in any other example you will observe that the ratio is greater than 1. So be careful. All these formulas depends on the ratio, right? Whether it's a less than 1 or greater than 1. If it is a greater than 1, formula for Sn is a times, just revert the thing, so it's a r raised to n minus 1 divided by r minus 1. Obviously these formulas will save your time. Instead of adding all the terms manually, if you apply these formulas, then you will get sum very quickly. Then here I am discussing this case number 3, which is very interesting one. What if the ratio of successive term is 1? So friends, let's try to understand this case number 3, which is very, very interesting one. So just ask yourself, how about which kind of sequence gives you the ratio 1 consistently? So if you take a ratio of two successive terms consistently, then throughout just keep that ratio equal to 1, then what kind of sequence that you will observe? So right, so here if you want the ratio of successive terms equal to 1, then obviously each and every term of the sequence must be same, then and then only it is possible. If I say every term of the sequence is 5, then friends, what is 5 divided by 5? It is 1. 5 divided by 5, 1. So if you want a ratio of that sequence equal to 1, then obviously if you want this ratio equal to 1, then each and every term of the sequence must be same. Then and then only you will get ratio equal to 1. So right, then how to find Sn? So we use this case number 1 if r is less than 1. If r is greater than 1, then we use case number 2. But we cannot use these two formulas if r is equal to 1. For r equal to 1, you have to do something different. Okay, so let's understand this thing in a simple way. So friends, if you add two terms in such a sequence, 5 plus 5 is 10, but we can express this 10 as a 2 into 5. But if you add three terms of such a sequences that leads to 15, means in this case we can express it as 3 into 5, right? What if you add 4? See, real logic lies in understanding this expression. So this is 20. Let's express this 20 as 4 into 5. So what is your observation? If you add 5 two times, answer is 2 into 5. If you add this 5 three times, answer is 3 into 5. If you add this 5 4 times, answer is 4 into 5. What if we add this 5 for 1, 2, 3, 4, 5, 6 and 7 times? So obviously your answer is 7 into 5. Try to understand. I am trying to create a formula for this. If you add this 5 7 times, so answer is 7 into 5. Then what if we add this 5 for n number of times? We want to add this thing for n number of times. What if we add this 5 for n number of times or n times? So obviously if this 5 is added for 7 times, your answer is 7 times 5. If this 5 is added for 4 times, your answer is 4 times 5. On the basis of this observation, if you add this 5 for n number of times, your answer must be n into 5. So on the basis of this, let's derive a formula for a sequence whose R value is 1. So if R is 1, then the first term itself reflects in each and every term of that sequence, right? So let's say this is up to n times. Then this is a sequence in geometric progression in which the ratio of successive term is 1, and if you want Sn in this case, make sure that you add all these A for n number of times. So right, n times, and try to analyze this result on the basis of what we discussed in this example. If you add this 5 for n number of times, answer is n times that 5. So in this case, we are adding this A for n number of times. Then in that case, formula for Sn is n times of that digit or n times of that A. So this is the formula that you have to use for Sn if R is given equal to 1. So there are 3 cases for the formula for Sn. Try to observe which one of the following 3 cases is possible in the example. So you might will observe the ratio is less than 1. So case number 1. So we are discussing how to find sum of first n terms of geometric progression, or nothing but Sn. Finding a Sn means addition of all n terms, right? So there might, you will face 3 cases. The ratio may be less than 1, ratio may be greater than 1, or it may possible that the ratio is also equal to 1. The case number 1, if R is less than 1, then please use this formula for Sn. So formula for Sn in this case is A into 1 minus R raised to n upon 1 minus R. If R is less than 1, please use the second formula for Sn, that is A into R raised to n minus 1 upon R minus 1. But this is the interesting case. What if R is equal to 1? Then you will observe this kind of sequence, and if you try to add all such terms, answer in this case is Sn is equal to n times A. So that's all, friend. This is all about basics of geometric progression. In next session, definitely we will cover few problems on nth term as well as sum of n terms of geometric progression. Before that, please revise this thing once again and be ready with the data, and definitely this data will help you in solving the problems on this. In next lecture, we will see few examples on nth term as well as sum of n terms of geometric progression. I hope this session will help you in solving the problems. So definitely in next lecture, we will cover all the problems on this geometric progression. So don't miss that. And here I am signing off. Goodbye and take care.